Okay, in this proof, typically we want to start with the side where there's two terms and then work to the side that has one term. However, the side that has one term has this strange angle 3x, so I don't know a way to create an angle of 3x, so I'm going to start with the left-hand side and try to get the right-hand side. So my goal is going to be to try to split this up into two terms like the right side. So the first thing I'll do is rewrite sine of 3x as sine of 2x plus x, right? So this is all over sine x cosine x. And I did that because now I can use my addition formula for sine to split the top up. So the addition formula for sine says this would be sine of 2x times cosine of x plus sine of x times cosine of 2x. And all of this is over the denominator sine x cosine x. So now I can split this into two terms by putting this over the denominator for one term and putting this over the denominator for the second term. So let's do that. So I've got sine of 2x cosine x over sine x cosine x plus sine x cosine 2x over sine x cosine x. Now I can have a little bit of fun and cancel the cosines here, cancel the sines here. And now I'm going to use my double angle formulas to replace each of these. Sine of 2x, the double angle formula says that's 2 times the sine of x times the cosine of x. Now that's over the sine of x plus cosine of 2x. There are three different versions. I'll write them over here to the side. So we have to decide which one we might want to use. So what I'm going to do is look at the result that I want up here and see which one seems to work better for me. So my first thing I noticed is this term has a cosine, so I need a term with a cosine for sure. And this term is secant, which is the reciprocal of cosine. So both of these terms will have cosine, so I want to make sure to use the one that involves just cosine and maybe no sine. So I'm going to use this double angle formula for cosine of 2x, and I'll put that on top here. Okay? And the first one is nice again because the sine x's cancel. So the first term is just 2 cosine of x. And now the second term, that's close. We have 4 cosine of x, and we need 4 cosine of x, and we have 2 cosine of x. So I need to add something to this. So what I might do is use the same principle as before and split this fraction up where this term is over cosine for one term, and then this term is over cosine for another term. So that looks nice because if I do that, this right here, negative 1 over cosine of x, is the negative secant of x that we're going to need. Okay? So I end up with 2 cosine squared of x over cosine of x, right? Just putting this first term over the cosine, minus 1 over cosine of x. And so what we have is 2 cosine of x. Here, this cosine cancels with one of those, so we've got plus another 2 cosine of x minus 1 over cosine of x. Finally, I can add the two cosines together and get 4 cosine of x minus 1 over cosine is secant of x, and that is the right-hand side. So we use the addition formula for sine, the double angle formula for sine, one of the double angle formulas for cosine. We use this idea that you can split fractions up. You can put each term over the denominator, split the fraction. We use that concept twice. Okay, so several things going on here. Very good proof.